Hi everyone, welcome back. So in this video, we will continue what we've been doing in the previous video. Today we will talk about the first order linear ordinary differential equation. And the linear differential equation will be in the form of dy dx or y-axis plus pxy equals to qx, and this is the general form of a linear differential equation. Without further ado, let's go to our first example. So this is our first example. What we have here is that dy over dx plus 7x to the power of 6 times y equals to x to the power of 6. So what we have here is the first order linear differential equation. So how do we solve this? First, we know that dy over dx is y-axis, or the derivative of y, plus 7x to the power of 6 times y equals to x to the power of 6. And remember, first we will need to find the integrating factor. But let's define the variables here first. Px is 7x to the power of 6, while qx is x to the power of 6. And our integrating factor will equals to e to the power of the integration of px dx. So we've defined all of the variables here, which is px and qx. And now let's just plug it in to find the integrating factor. What is px? Px is 7x to the power of 6, and we're going to integrate it with respect to x, and this will just become e to the power of x with power of 7. And don't forget, don't add a constant here, because we just need to find an integrating factor, and we're gonna add a constant later on our main integration. Let's move on. Let's multiply this whole equation, that our first equation here, with e to the power of 7 with e to the power of x with power of 7. So this will become e power of x power of 7, the derivative of y, plus 7x to the power of 6 times e with power of x with power of 7 times y equals to x power of 6 e power of x with power of 7. Now let's check if we've done all of our steps before correctly. Now we know that the derivative of e to the power of x to the power of 7 is equal here, and the integration of this one is equal to this thing here. So we know both of them are equal to each other if we integrate it or differentiate it, and so all of our steps here are correct this far. And so d over dx times e to the power of x power of 7 times y. Don't forget the y here because we want to make it into a y equals equation, equals to x power of 6 e power of x power of 7. And how do we get rid of the derivative on the left side here? We just need to integrate both sides. Remember, we just need to integrate both sides. And so this just leaves us with e to the power of x with power of 7 times y equals to the integration of x power of 6 e power of x power of 7 dx. And for the integration here, I'm just gonna do the throwback method because it's simpler for me that way, but you all can use a u substitution method because that's a more general way. But I prefer the throwback method, and I hope that you guys try to do the throwback method because it's way much easier. And so e to the power of x power of 7 times y equals to the integration of x power of 6 times e power of x power of 7 d. I want to differentiate the x to the power of 7, and the differentiation of x to the power of 7 is 7 times x power of 6, and this way we can get rid of the x power of 6 here, and this just leaves us with the equation of 1 over 7 e power of x power of 7 plus c. Don't forget to add the constant here, okay? Not in the integrating factor, but in the main integration process. And from here on, it's gonna be simply just algebraic manipulation where you times or multiply both sides by e power of x power 7, and you also multiply this side by 1 over e to the power of x power of 7. And so, if you multiply this by e to the power of x power 7, this will be gone, so it will be 1 over 7 plus c over e power of x with power 7. And this is our final answer, which is the general solution. And before I've stated that I have two methods in solving this first order linear differential equation, which is actually it's not a two method, but the other method just gives you a formula with which all of you likes, of course. You just need to plug in the numbers and do the integration, and I'll show it on the right hand side here to prove that both methods shows the same exact answer. Let's see. We have y derivative plus 7x power of 6 times y equals to x with power of 6. And the formula to it is just y equals 1 over the integrating factor times the whole integration of the integrating factor multiplied with the qx dx. And let's just plug in the numbers that we've got before. 1 over the integrating factor, which is e to the power of x with power of 7, multiply with the integration of ix, or the integrating factor, which is e to the power of x power of 7 times qx, and qx is x power of 6 dx. And we're going to use the same integration method, which is the throwback or use substitution, whichever that you like or prefer most. And we're using the same method again, which we're going to differentiate the x power of 7, and it will give us 7x power of 6. We can cross out all of the x to the power of 6 here. 1 over our integrating factor again, and we multiply everything by with 1 over 7 e x to the 7 plus c. Don't forget the constant there. And this just gives us our final answer will be, if we multiply this inside here and inside here, this will give us simply 1 over 7 plus c over e to the power of x power of 7. And both our answer equals to each other. And we know then both method works, and you can choose which method suits you the most. Either you want to do it manually, like the right hand side here, or you want to do it based on the formula where you just need to plug in the numbers and you don't need to think of other else. You just need to find the integrating factor. And this is it for the first example. Now let's move on to our second example. Hi everyone, we're back with example number 2 for first order linear differential equation. So what we have here, we have the derivative of y equals to 4y plus x squared plus 5. And don't panic right here, because what we need, or we want to do is just to make this equation right here is in form of the first order linear differential equation, general form. So we want to subtract both sides by 4y, and it will give us y squared minus 4y equals to x squared plus 5. And so right here, we're good to go to solve this linear differential equation. And first, let's define the variables here. We have, for px, we have negative 4. Don't forget the negative sign here, because I've seen a lot of students forgetting their negative signs and end up with another result. And our qx here is x squared plus 5. And we need to find one more thing. What is that? The most important thing, which is our integrating factor, which we will integrate it towards px with respect to x, and e to the power of the integration of negative 4 dx, which is simply just going to be e to the power of negative 4x. And don't add constant here, like I said before, because we just need to find the integrating factor. Let's move on to the next step. Let's multiply everything here. Oh, this is not y squared, this is y accent. We need to multiply everything here with our integrating factor. And so we have e to the power of negative 4x y accent minus 4e to the negative 4x times y equals to x squared e to the negative 4x plus 5e to the negative 4x. And recognize why I don't just simplify the e to the negative 4x on the right hand side and put it outside, because it has an x variable, and so it is not a constant and we need to integrate it later, and that's why I multiply it for each variable. And so let's move on. Let's check our steps up to here. So have we done all of the steps properly? Is our integrating factor correct? Let's see. The derivative of this thing here is equals to this thing. And the integration of this thing here is just equals to this thing back. And so we've done everything correctly and we're good to go. And remember, we're gonna take the derivative with respect to x of e to the negative 4x, our integrating factor, times y, because we want to make it into y equals equation, equals to x squared times e to the negative 4x plus 5e to the negative 4x here on the right hand side. And we want this differential to be gone, and so let's integrate both sides. And this just leaves us with e to the power of negative 4x times y equals to the integration of x squared times e to the negative 4x dx plus the integration of 5e to the negative 4x dx. Recognize here, I split our right side into two integration, because for this side it is pretty easy how to integrate this one, but for the left side here we need integration by parts. So it's better to split it into two integrations, since we need to use both two different integration methods. Okay, so let's integrate this side first. X squared times e to the negative 4x dx. If you have taken Calc 2 and Calc 3, basically Calc 2, you've known by now, by this step we're going to do, is that we're going to do integration by parts method. But I have a more simpler way, which is still using the integration by parts. Usually, you would use u times phi minus the integration of phi times du. You would substitute everything inside again later. But for me, let's use the Tanzalin method. So remember, we have two sides. Our left side, we're gonna differentiate it, and our right side, we're gonna integrate it. So what do we want to differentiate and what do we want to integrate? We want to differentiate the x squared here, and I'll tell you why in just a second. Why do we want to integrate x squared? Because if we, differentiate the x squared, because if we differentiate the x squared, it will becomes 2x, and then if we differentiate it one more time, it will just become 2, and if we differentiate it one more time, it will become 0. And that is the point why we chose x squared to differentiate it. And so let's move on with our right hand side. Let's integrate this one. This will become negative 1 over 4 e to the power of negative 4x. One more time, we will get 1 over 16 e to the negative 4x, and one more time we will get negative 1 over 64 e to the negative 4x. And for the signs, plus, minus, and plus it equals to, so this will become negative 1 over 4 x squared e to the negative 4x, and for 2x and 1 over 16 here, we will put a negative sign in front, and 2 times 1 over 16 is just 1 over 8, so basically that's minus 1 over 8x e to the negative 4x, and for the last one here, 2 times negative 1 over 64 will just be negative 1 over 32 e to the negative 4x. And we've done, or we've successfully integrated our left hand side, which is here. And so for our right hand side, which is here, it will just simply be dx. It will simply just be negative 5 over 4 e to the power of negative 4x. And don't forget to add a constant. Just add one constant to whichever integration you want to add. Just add one constant, because remember, constant plus constant is just a constant. So just add one to not confuse you later on. So we know that we've got our integrations for both of the integration. So e to the power of negative 4x times y equals to negative 1 over 4 x squared e to the negative 4x minus 1 over 8 x times e to the negative 4x minus 1 over 32 times e to the negative 4x. Don't forget the other integration, which is minus 5 over 4 e to the negative 4x, and don't forget the constant here. And from this step, everything is just easy. If you want this to be gone right here and make it into y equals equation, you need to multiply both sides by e to the 4x, as well as this side by e to the 4x. So we lose the e to the power of negative 4x in the left hand side, and for the right hand side we have negative 1 over 4 times x squared. We lose this one because of this here, minus 1 over 8 times x, and we will lose this as well because we will multiply it by e to the 4x, and minus 1 over 32 here, and we will lose this as well because we will multiply it with this. And for the last one is that minus, we will lose this one as well because we will multiply it by this, negative 5 over 4 plus c. And we're gonna multiply c here with our e to the power of 4x, and so this will give us c times e to the 4x. And if we simplify this equation, it will be negative 1 over 4x squared minus 1 over 8x minus 1 over 30, negative 1 over 32 minus 5 over 4 is minus 41 over 32. Don't forget, plus c times e to the 4x. And this here is our final solution because we cannot simplify it any further. And so this is how you solve for the second example for first order linear differential equation. Hi everyone, we're back with our third example for first order linear differential equation. So let's get into the problem. So we have here x squared times yx and plus x times x plus 2 times y equals to e to the power of x. So first, what I like to do is I like to distribute this thing inside here first, and you'll see why I will do it. So it will be x squared plus y accent plus, don't forget the brackets here, x squared plus 2x times y equals to e to the x. And you'll see that we have this x squared in front of y accent, which is not allowed in a linear differential equation. Because in front of the derivative of y here, or y accent, it must be a constant of 1. Okay, so you need to divide everything here by x squared. And so this will give us the equation of x squared here divided by x squared there will just be 1 plus 2 over x y equals to e to the x over x squared. Okay, after this step, we're good to go. We've made this equation first into the general form of linear differential equation, and so we just need to define the variables. What is px? Px is 1 plus 2 over x. What is our qx? Our qx is e to the x divided by x squared. And what is our integrating factor? Remember, it is e to the power of the integration of px dx. What is our px here? E to the integration 1 plus 2 over x dx, and this will become ex plus ln or ln. It's actually 2 times ln of x. Okay, we can simplify this for the sake of our calculations later on, times e to the into 2e to the x times e to the ln x squared. And we know we can get rid of this part. This will just leave us with e to the x times x squared. And so we have our integrating factor. Let's multiply our equation here by our integrating factor, which is x squared times e to the x. This will give us x squared e to the x y accent plus x squared e to the x 1 plus 2 over x y equals to e to the 2x, because the x squareds cross each other. And so after this step, we will do the same thing again, which is the derivative of our integration factor or integrating factor, which is x squared times e to the x times y, because we want to make this into y equals equation, equals to e to the 2x, and let's integrate both sides to get rid of the derivative on the right side, which gives us x squared times ex times y equals to the integration of e to the 2x dx. And so on the right hand side, after integrating it, we will get 1 over 2 e to the 2x plus c, and then we are gonna multiply everything by 1 over x squared e to the x here, and on the left hand side just leaves us the y. On the right hand side we will get 1 over 2 e to the 2x times 1 over x squared e to the x, will gives us e to the x over 2 times x squared plus c over x squared e to the x. And here is our final solution, which we can simplify it by pulling out of the 1 over x squared. For the sake of simplicity, times e to the x over 2 plus c over e to the x. And here is our final answer to this linear differential equation.